is sitting on quicksand. There's something terribly wrong that's gone wrong in physics. And this society is the first society to start to acknowledge by my work that something is a little strange going on in physics, that we haven't quite mastered what's going on. There are all sorts of bizarre effects that we observe experimentally, but it turns out they're not quite coming from the standard treatment of special relativity. So what happened, once you discover that there's a flaw in the whole apparatus, it doesn't take very long to figure out how to fix it up. It's really simple stuff. And this has led to a new theory of gravity, which one can check out quite easily. It explains so many things. It doesn't need dark matter and dark energy, all these phantom entities that were invented to save the prevailing theories. And it turns out that there's a new theory of gravity, and it's a theory that's so simple that Newton himself could have formulated. It's just quite simple mathematics. The only reason Newton didn't do it was that he didn't really have a reason for doubting his own theory. And this new theory has two constants in it. Most theories of physics have a couple of constants which you have to discover experimentally. And one is the famous Newton's constant, big G, that the physicists know about. And there's another constant which gravity experiments have told us has the value 1 over 137, a very famous number in physics. Most physicists know about that number because it's the number that determines the behaviour of atoms and molecules in chemistry. And it turns out the same number turns up when you analyse gravity experiments. So this is telling us something very fundamental. It's telling us that gravity and the quantum theory of matter have something in common. And that wasn't known until quite recently. And so that's suggesting that there's quite a paradigm shift unfolding. That in fact space is a lot more complicated. It's a dynamical entity. It's actually moving past us at enormous speed. It's been detected by so many experiments that I've actually lost count of them. And even though I am a theoretical physicist, I've broken all the rules by starting to do experiments because it's so easy to observe. And so I'm having a lot of fun. I didn't realise how exciting experimental physics was until the last few years. And I've actually converted a part of the house into a laboratory, much to my wife's displeasure. But anyhow, science has to be pursued. All of these developments were starting to be predicted some years ago in a new thinking about the nature of reality. And in this new theory, which is called process physics, it suggests that reality is far more complicated, a far more complex system than anybody in physics had ever considered. Although outside of physics, I've found lots of philosophers and so forth who were thinking along these lines over the years. And it turns out what the physicists are doing is converting some metaphysics into physics by discovering that there's actually experimental data that supports some of these very old ideas that go back a long way. One of my heroes is Heraclitus, who was around talking about process physics 500 BC in Ephesus. And so this is leading to a whole lot of new ideas about the nature of space and time. And most importantly, all of these ideas are testable with experiments, mainly by other people. I wouldn't trust my own experiments. I've made enough mistakes already in the few I've done not to be totally trusting of my own experiments. But the experiments that have been done by many people over a long period of history are all coming together. All of the anomalies, all the bits and pieces that didn't quite fit together and were pushed under the carpet, you've got to pull them out and reassemble all the evidence and discover that something else is going on. And so it's a very dramatic time. It's been a great personal battle, as Jeremy and the others have suggested. If you ask questions about the fundamental belief system, as Galileo discovered and Bruno discovered and everybody else who's ever had an original idea in their life discovers, you suddenly find yourself in a lot of trouble. And I've certainly found myself in a lot of trouble. And so I really do appreciate the recognition of my work by the Society and by the University here. And I wish the best for the University and for the Society in the future. Thank you all very much.
Well, I think, ladies and gentlemen, the first thing I ought to say is that I'm not going to risk asking Mrs. Cahill to comment on a few of those remarks in Reg Cahill's address to you. I think it would be